In this video, I wanted to just walk through a few examples of the implication of class inheritance when we're looking at code and reading code. So I have some code over here to the left. We have class A, and inside A we have fields A and B. A is private, B is public, and then it also has a couple of member functions, set A and get A, that allow us to set the A member field to a value or return the member field. And then class B inherits from class A. And inside class B, there's a private field C. And then B has a constructor that'll initialize the B field from A to 0 and field C to some value we pass in. And then there's this function sum that'll add up A, B, and C. And I'll point out to you that this get A is the get A function from class A that it inherits. So we can call that because it's a public function. And then B is a public field from class A that is able to access. And C is its own field that's private. Okay, so let's say we declare this variable little b of type B and pass 6 to its constructor. And so when we pass 6 into the B's constructor, that means that we're going to initialize field C to 6 and B gets set to 0. Okay, so then the next thing I do is I say B dot set A. And so if you look at this, you see that inside B there is no set A function, but B inherits from A the set A function. And since it's public in A, it's also public in B. And so we can call set A and pass in the value 0. And so what that means is when we pass in the value 0 to set A, it means we're going to set the field A to 0. Now B has a field A that it inherits from class A, but it's private, and so it can't directly modify it itself, but it can modify it through this set A function call. Okay, so this sets our field A to 0 within class B. B dot B equals 5. What's happening here is that within my B object, I inherit field B from A, and it's public, which means I can just directly access it publicly and set the B field equal to 5. Here I use cout to print out the result of calling sum on class B. And so this is going to get A, call get A, and then add B, and then add C. So get A we just initialized to 0, B we just set to 5, C we set to 6 when we constructed the object. So that's 0 plus 5 plus 6. So that means this would print out the number 11. Okay, now if I tried to set B.C, if I just wrote B.C, now the problem is C is a private member variable, and so that's going to be a syntax error because it has nothing to do with inheritance. It only has to do with class B. And likewise, if I wrote B.A, now this is a problem because A is a private member of class A, and when B inherits from class A, it inherits a private copy of A, which is not allowed to directly access. So B.A is a syntax error. And not only is class B not allowed to access A, but no other code's allowed to access it either. Okay, so this would also be a syntax error. So when you read a description for a class like B, it's not enough to just read what's in B. You have to come back up and look at what's in A and think about what A is providing to B. And A is providing to B directly anything that's public. So B, any of B's member functions can call any of these public functions within A. Any object B, if you have an object of type B, you can call any of the public member functions of A, or you can call any of the public member functions of B. They're all available directly on the B object. And any public member variables, either from A or B, are going to be available on this B object. So you have to look through both classes and in order to understand what you can do and what's happening on this object.